The length of the Brittany coast will depend on whether you're an ant, a rabbit, or a human. Find out how fractal geometry was discovered and subscribe to our series, The History of Math. Mathematics were a key element in the development of computer science. No mathematics, no computer. This is obvious. But somehow, a computer is a thankful object. Thanks to computer science and thanks to those powerful machines, a new era started in mathematics. New disciplines of mathematics made possible by the development of computer science. And one of the most famous examples of this is what we call the fractal geometry. Geometry was developed long time ago. We have talked about Plato and Pythagoras and others. And thanks to the computer, a new kind of geometry became possible. And the founder is Benoît Mandelbrot, a French genius, worked as an IBM fellow, and he started his research with a very peculiar question. How long is the coast of Brittany? Looks obvious. Where is the problem? But the answer of Mandelbrot was unexpected. The length depends on who you are. If a human being, you walk the coast of Brittany and you have how many kilometers, I don't know. But if you're a rabbit, for example, and you follow the path, the coast of Brittany, it's going to be a longer path. Now imagine you're an ant. You have to do like this to just follow the coast of Brittany. And that was the starting point of Mandelbrot. Another thing is, if you look at this coast of Brittany, what the ant can see is similar to imagine an astronaut from the outer space looking at the coast. The ant and the astronaut see the same things. The only difference is the scale. And this is called self-similarities. Self-similarity is a property of an object which looks the same whatever the scale. And that's how Mandelbrot started this new geometry. There are many famous examples. Let's take two of them. The first is the snowflake. If you start with a line, like this, a segment of line, and then you do this, you just bit like a triangle. And on the side of the triangle, you bit a triangle. And then you bit it, and you always build a new triangle in the middle of the side. You finally get the snowflake. That's how Mandelbrot imagined to design the geometry of nature. He was looking for the formula of the nature, like the snowflake. He did the same for the clouds, a bit more complicated. And of course you need to draw, and that's why drawing are so important. Another example is this one. If you take a segment of line like this, and you remove what's here, you go one step below, and on the two remaining segments of line, you remove what's in the middle. And again and again and again, you will notice self-similarity. This little area here you see on the drawing is self-similar to this one. From the outer space, they look the same. This is self-similarity. And that was the starting point of the fractal geometry. And this brings us back to something we have seen before, how to prove with drawings. Imagine you asked to calculate the sum of 1/3 plus 1/9 plus 1/27, and you have the power of 3 here. How much is it? You can use a kind of fractal formula. You start with a 1. You divide in 3 pieces. Of course, you have to keep 1/3. You can drop 1, and you have to keep the middle one and do it again. You now need to calculate 1/9. So you cut it in 3 pieces. You have to keep 1, you can drop the last one, and you have to keep the middle one. You can go as far as you want. At any time, you have to keep one piece and drop one other. So the sum is 1 on 2. Next time we'll be looking at algorithms and how they can help us with practical tasks. Subscribe now to our series The History of Math and the YouTube channel What Makes It Tick.